take you to the practice quiz, question number 1. So here's 2 points. Place them, draw a, you might want to have an XY grid out. You could, if you've got your book, they've got plenty of XY grids and all kinds of pages in this chapter. You could use one of those or draw one on your own, but use the graphical method. Plot these 2 points, do the rise and run, and somebody's got their mic open. You might want to check, see.
Sorry.
All right, thanks. Okay, 30 seconds more. Okay, so first point, 2, -4 is here. 5, 2, 5 to the right, 2 up. And then I like to do my run first, but I could do the rise first. I'd get the same answer. How much do I run to go from this point to this point? 1, 2, 3. And if it's moving to the right, it's positive. If it's moving down, it's negative. And moving left, it's negative. Now up is positive, down would be negative. And then I go 1, 2, 3, 4, 5, 6, up. Now, this is slope m equals rise over run, 6 over 3, which is 2. Let me point out an alternate way that I could have gotten these 3 and 6. When I did if I look at the x coordinates of these 2 points, that 2 is here and the 5 is here. And I could have gotten this 3 by taking the rightmost of the second point minus the first. And that gives you that. Similarly, the -4 and the -2, let's do this in green. -4 and +2. And you take the one on the right minus the one on the left, or the one the one on the rightmost of these 2 listed points, to subtract -4. And that's how we could have gotten that 6 as well. All right, so that's the slope using the graph method. Find the slope using a formula. So do it again, get that slope. Thirty seconds more. Alright, so this is x1, y1, x2, y2, And then the slope, y sub 2 minus y1 over x2 minus x1. That's the slope formula. And then that's 2 minus negative 4. Exactly the same thing we're doing over here. The visual representation of that is the rise. And then this is 5 minus 2, 6 over 3, which is 2. Exactly the same answer. One by graphic method, the other by just plugging in the formula. And, alright, so give me a little feedback on number 1. Okay. Let's go to number 2. Graph the line with these properties. M is the slope, B is the y coordinate of the y-intercept. Thirty seconds more. Alright, we start with the y-coordinate of the y-intercept. That gives us a point on the y-axis. So there's the x, here's the y-axis. And then the slope is negative 4. Now when I make the slope, you cannot do it like this. This is how we make a fraction out of 4. Anything is itself over 1. But I don't want that negative sign level with the fraction bar. I want that negative sign with one or the other number. Now I could have put it with the bottom number or the top number. If I put it with the top number, then what I'm going to do is from this point I'm going to rise negative 4. Rising negative means go down. Go down 1, 2, 3, 4. And then run 1 ends up right here. And then I'd connect these 2 points to make a line. Now, suppose I had done it instead of like that, I had put the negative with the bottom number. Then my rise would have been 4 from this y-intercept. 1, 2, 3, 4. And my run would have been negative 1, sending me back to here. Now notice, I get the same line in the end whether I connect the bottom 2 points or the top 2 points. The line that goes through it all goes through all of these. Okay, and then give me feedback on 2A. Okay, let's go to B. So the directions, again, graph the line with these properties. M is the slope, B is the y-coordinate of the y-intercept. Graph this one. Okay, 15 more seconds. All right, the only thing we really got to do is put the negative with one number or the other, not with both, because the negative divided by negative is positive. B is 3, and then suppose I rise -3, and then run 4 would take me to here. So I don't have to make those little jumpy lines. I can just do it like this, and then I connect them. And that's an amazingly quick way to graph a line. If we know the y-intercept and the slope, boom, we can graph the line really quick. Alright, and also we can kind of do a make sense check. It's a negative slope, so going to the right, we should be going downhill. We should be losing money if this was stock market. Alright, this one's a little tricky. Do that one. Okay, 30 seconds more. Alright, so I'm going to blow this up so it's a little more. Alright, B is 1/2. So, right here. M is 1/4. Now notice I tend to do my rise first. And that's only because I say rise over run. But you could do the run first if you want. It doesn't matter. So rise 1 sends you to this halfway between 1 and 2. Run 4, 1, 2, 3, 4 sends me over here. So this one is like this. Okay, now let me point out this M could have also been thought of as -1 over -4, because that reduces to a positive 1/4. And if I had done rise -1, run -4, I would have come up with over here. And this line, my line should be going through that. It kind of went a little bit low than it should have. Okay, so either way would work. And all right, give me feedback on B and C. Okay. And simplify. Do it more than one way. So as soon as you get your answer, do it again. Do it a different way. As many ways as you can. Okay, 30 seconds more. All right, one way, yes. And we reduce 1 for 1. Divide by x, keep dividing by x. Another way. When you divide, you subtract the exponents. And oftentimes the directions are write your answer with positive exponents only, because a lot of people forget what negative exponents mean, or never learned it. So we move it down, get the same answer. A third way, we'll take the perspective of the denominator. Subtract the exponents. Get the same answer each way. A little bit of feedback on number 3. Okay, so there I'm kind of reinforcing something we did last time, but it's an important concept, so it's good to reinforce that. All right, that's it for the practice quiz. And when you were doing the homework on 3.4, the last part of it you may have had some troubles with, because we didn't get through everything. And so what I'd like to do is jump into 3.5 right now for today, and that might clarify if you had some question on 3.4, and then I'll take questions at the end today. But before we jump into 3.5, let me point out announcement. Oh no. Let's go to modules. Graphing systems of linear equations. All right. I don't see the final exam up here. All right. So I haven't made that visible to you guys yet. So it's a good thing I'm checking here.
Hold on, it's visible from where I'm at.
You see it?
Yeah, actually, it's right here.
All right.
Maybe if you just put it in just to be sure, because let me see. Yeah, I see it.
All right. Let's say leave student view. So I'm in the modules. Practice, final exam review, and final exam. That's there. Okay. So on the final exam review, well, let me point out, it says to skip the following problems. Don't do those. We didn't get that far. And then the final exam review, open it up. At the end, it has the solutions, the answers. And what you want to be doing, though, is if you're getting benefit from the practice quizzes, you want to do your final exam in a similar style, which is exercise your memory as you do it. The most common mistake that people make when reviewing is they don't exercise their memory. They say, ooh, this problem looks kind of uncomfortable to me. Let me go and see how it's, see what the answer is and work backward from the answer, and, that, it's like you're weightlifting without lifting the weights. You're not going to get nearly as much benefit out of it. If you force yourself to guess, and then you later find out that it's wrong, you have something to work with to say, when I finally did it right, this is what I was doing wrong. So on, you can identify. You'll tend to make those same mistakes again, or not even discover that you would have done it wrong, and then make that mistake that you would have made at the final exam. So it's really good. The mistakes are what we learn from. And all right, any general questions before we move on with 3.5?
On my end, it says the final exam unpublished module and it's not available.
The final exam should be not available right now.
No, this is for the review.
The final exam review?
Yeah.
It says it's not available.
No.
On my side, it's available. Try refreshing your page.
No, mine says no, not available too.
Oh, really?
I try on my, I try on mine just to open it right now.
Oh, yeah, you're right. It is unavailable.
When you click on it, it says it's unavailable.
Correct.
Yes.
And when I go into student view, something crazy happens too. Wow. All right, let me go back into this in student view and see if it's there again. No, it's not there. And you guys are finding it unavailable. All right. What I can do during the break,
It's under assignments, but it doesn't let you view it.
It doesn't let
So
you
if you
open.
go, no, if you go on assignments on student view, you'll be able to see it.
So, student view, assignments.
I tried that. It didn't work.
Practice. There's final exam review. Unpublished module. Ah, okay. That might give me the hint. All right. Let me go into the modules again. All right. Finally, the module itself is not published. Ta-da! Now it should work if you refresh your screens.
Yep, it works.
Yes, yes,
Great.
it works.
All right. Glad we got past that. Thank you for your help. All right. Anything else? Thanks for pointing that out. Ooh, that would have been a biggie if you couldn't get access to your review.
Wait, I do have one more question.
Yes.
On the review, are those not going to be on the exam?
Correct.
Okay, thanks.
You're welcome. The ones that you're not supposed to do for the review also will either they will not show up on the exam, or I'll say don't do these or something like that. Yeah, we'll make sure you don't have to do that. And anything else?
Can I ask a question on the homework or not yet?
Go ahead. If it's
Okay.
on the part that we just didn't get to, I'll just delay that.
Okay. It deals with, it's on 3.4, so it's 36 and 42.
3.4, 36. Yes, that's the stuff that we're going to get to right now. So you'll be able
Okay.
to get to it. Okay?
Alright.
All right,
Okay.
so let's jump into this. Finding the equation of a line. All right. So far, the fastest way to graph a line has been to use the intercept method. Today, we'll find an even better way. It's a way that we almost always use. And to rent a mountain bike, it costs $2 and then $3 per hour. All right, so if X is the number of hours, Y is the cost. I'm going to give you a small amount of time to complete this table. And so let me give you a quick minute for that. All right, and if you're in group 1 or 2 and you're here today, I want you to join group 3. And I think we have groups 3, 4, and 5 that have been stable. So I'm just going to assume that today. Groups 3, 4, and 5. Check in real quick with your group. Just say hi so everybody knows who's here. Make sure that you know who the spokesman for your group is. We'll go with groups 3, 4, and 5. Okay, when you get these answers, quickly type them into your group chat. Okay, group 5, what do you have for this table?
We have nothing yet. I have 1 hour, $5.
Yes. And if we keep with that progression, the next hour costs another $3, so it'll be 8. The next will cost another $3, that would be 11. Okay. So if you rented it for, a minute, they'd still charge you this $2. But otherwise it's by the hour. All right. And the modeling equation for that is y equals 2x plus 3. And let me just demonstrate. Y is 2x plus 3. When x is 1, you get this 5. When you put in 2 for the x, there's 2 times that you got charged the, hold it, cost $2 and $3 per hour. I mixed these up. 3x plus 2. That's right. All right. So let me fix this in my notes. Okay. So when you put 1, you get 5. When you put 2, you get 6 plus 2 is 8. It's just that how many times are you getting charged the $3? It depends on how many hours you did. So the number of hours multiplied by the cost per hour, plus the one-time $2 fee. So it makes sense that this is the modeling equation. The input variable x is the number of hours, and the y is the cost. All right, So we have a context. We kind of know what this y equals 3x plus 2 represents now. Let's graph this and then figure out what the 3 means in the graph and what the 2 means in the graph. So we've got a bunch of points. Take these points, stick them into a graph, and graph it. I'm going to give you about 15 seconds to get ahead of me, and then I'm going to do it. So I take these points and blow it up a little bit. 0, 2, 1, 5, 2, 8, 3, 11. So then we have this question. What does the 2 mean in terms of the graph? And what does the 3 mean in terms of the graph? So, discuss that in your groups real quick. I'm going to ask a group in a minute. Okay, group 4. What does the 2 right here, what does that mean in the graph?
I think it's we said it's the 2 is the run.
Is the 2 the run? Now if you move from one point to another point, I think we only run 1. And then we rise 3. So I
Whoops.
don't think the 2 is the run. That's a very reasonable guess though, putting rise or run or something like this. But it doesn't look like it really matches up with this graph. Where is this 2 showing up in this graph?
Isaac just said the y-intercept.
Yes, showing up this shows up right here. Now, why is it that a number in this position, so we're going to be looking at more than just this graph, any equation that's in this format, like y is equal to 2x plus 6. Either one of these is going to be the y-intercept. Here or here. It's in that position. Now, this format that we're looking at is y equals mx plus b. If it's solved for y alone, and then the x part comes first, and then the other part after, then it's in what we call y equals mx plus b format. And when you have the number in the b position, that's going to be technically it's the y coordinate. Of the y-intercept. Now, why does the y-coordinate of the y-intercept always show up here? Well, remember, and I had this in the practice quiz last time, what's true about every y-intercept? Its x-coordinate is 0. For a y-intercept, x x is 0. It means you don't go right, you don't go left, you just stay on the y-axis. All right. Now, what does that mean? That means that if you were making a table, if you're trying to find the y-intercept, you set the x to be 0. When you set the x to be 0, it zeroes out this, it zeroes out this. The mx portion, let me come down, will get zeroed out, and the y will always equal b. That part gets zeroed right out when x is 0. So, thus, it makes sense that the b, whatever's in this position over here, is always the y-intercept. Alright, back to group 4 again. What does the 3 represent? Where does that show up in this graph?
That would be the slope, wouldn't it?
Very good. That's the slope. Now, it shows up only in a kind of abstract way. Let's look. It shows up as, if you go from this point to this point. Let's move. Run equals 1. Rise equals 3. And the ratio of the rise to the run is going to be that. That is the slope. So, slope always shows up in these positions. Now, remember we talked about what the slope meant last time, and one of the things that we talked about it was the rate of change. I gave you the stock market, and I said, how fast is this stock rising? And notice, in this situation, you have a $2 charge. How much does your cost go up every time you rent it for 1 more hour? What's the rate at which the y is changing? Very similar to how much is the stock going up every time 1 day goes by. This could also represent a stock that started out at $2 a share, and every day it went up $3 per share. So the number of days gets multiplied by 3. That is how fast this variable is rising. So that's the slope. It's going to be in that position every single time. So when we see any equation in the format y equals mx plus b, the m represents the slope and the b represents the y-intercept. So again, let me just point out, why does the b represent the y-intercept? Because x, y, which is equal to mx plus b, when you plug in 0 for the x, it zeroes this out. No matter what the m was, it makes that part 0. And so then this will become b. And this is our incredibly fast way that we'll be using to graph equations of lines now. Any questions? All right, so now let's use this really fast method. Graph y equals 4x plus 1. Let me give you a brief minute to get ahead of me. Alright, so this is the y-intercept, the y-coordinate of the y-intercept. This is the slope. So I'm going to use those two facts to graph this. Let me blow it up a little bit. The y-intercept is what you start with. 1. And then the slope is 4. So I'll make a fraction out of that. Anything to the self over 1. So I'm going to rise 4, run 1, and then I graph 1. So if you can do the practice quiz problem number 2, which was, oh, look at, I was even using this notation. B is the y-coordinate of the y-intercept. M is the slope. Now I'm just putting the m and the b inside an equation. That's the m position, the 4, and the 1 is the b position. Alright, so now you do part B. Okay, group 3, can you step me through step by step? What's the first thing I do?
I don't have any results in at the moment, but
Yeah.
I would say you would graph it first, I believe.
Yeah, what part do I do first? Shall I do this -2 first or the 3 first?
I believe you should start with the -2 first.
That is a really common student error. That tells you the slope, so how much to rise and run, but you don't know where from. And a common student mistake is they'll start at maybe the origin or something. But you have to start at a specific point. So we do this one first. We take...
I just got a result in. One student said start with 3.
That's right. So 3 is the y-intercept. And now, how do I do this slope? How do
This is Amalia. Can I answer?
Yeah.
So you rise -2.
Mm-hmm. And then what do I do on the graph?
And then you run 1. So you rise -2 and then you run 1.
How do I rise -2?
You go down.
Right. And then how do I run 1?
To you right.
Very good.
So yeah.
That's it. And then I'll put these two together. And I got it. All right. So first thing is always the y-intercept. Next, make a fraction out of this slope and do the rise and the run. All right, do it again. But this one isn't in y equals mx plus b form. So it's got to be in this form for us to do it. If it's in this form, you can't do it. So what we do is we take this equation and we put it into y equals mx plus b format. Now, to put into y equals mx plus b format is basically you just solve for y. So I got to get 2y by itself, so I'm going to subtract 4x. and then I'm going to divide both sides by 2. Now I could put a giant 2, the whole fraction over 2, but look at the format is supposed to be something times x plus b. So instead of putting a giant fraction bar, you do 1 over each term. Y equals negative 2x plus 3. Okay, so now go ahead and graph that. So I'm going to start with the y-intercept, 3. I'm going to do my slope, change this into a fraction. Top number is the rise, so I go down 2. Bottom number is the run, I go to the right 1. 1 mark right there. I connect these two. And this is the method that we will use from now on. Is we'll put every equation into y equals mx plus b format. And then we can graph it really fast, and we actually know quite a bit about the line even without graphing. We can tell what its y-intercept is and what its slope just from the form that the equation is in. All right. Now this format, y equals mx plus b, has a name. It's called the slope intercept form of a line. Why is it called slope intercept? Because the slope is there and the y-intercept is there. And you can immediately tell what these two things are if the equation is in this format. So this will be our preferred format going forward. And we are at a break time, so let's start again. At 1:35 p.m. And is there anybody who needs to speak with me individually before I take my break?
It's in regards to those 2 questions that I had on 3.4.
Yes.
Um,
We'll
So
get to those where I'm almost ready for them.
okay.
Okay.
Sorry about
We'll get to those. We'll get to those after the break then. Thanks for the reminder.
All right. Sorry about that.
No problem at all. Okay, anybody else? Check out the what? Dog door is now open. Yeah. Go in and out whenever you want.
It says Grover's Park in front. Did you see them in the backyard? Did you see people in the backyard at all?
No, never hear of these in a short time. Is the flag still there? They put up some red flag. Yeah. Yeah, they dug it up. And the flag is gone. So they went back there. See them for Christmas. But it'd be nice to know if they caught the one in the back. It says, huh.
Okay, so we have a check for 105 today.
Oh, 105. No, this doesn't.
No, this one says 35. This one says 35, and this one says one go for top, and that says two go for top.
Second one is replacement.
Really?
I'm pretty sure.
Well,
But we can check them again.
I just didn't. I want to stop with Dad for about 10 minutes. And then Dinah. And then Jennifer. That's just it's such a neat thing. It's such a nice.
Is it you?
He said, well, Dinah's not taking care of herself. That's why such and such happened. Really?
Oh, we just, no. It's there.
Well, mine also says, Teresa, if mine needs to go someplace and the doctor said Bill can't be left alone, he would ask Teresa to come stay with his dad. And she said, well, you know what, that's just one suitcase to babysit. And Teresa was amazed that she doesn't, that Nana doesn't take her daughters to take care of her. You might, so I'm willing to pay her, but you know what? She said, I'm not paying her to cross her legs when her dad crosses her legs. Or to uncross her legs when her dad uncrosses his legs. You know? She said, so that's what I'm used to doing. You know? Teresa said, I moved to California so I could help my dad. But I don't see what she's doing this often. I should call her and say, have you visited Dad today? You call him? She didn't answer that. I don't say that. Well,
All right, I'm back to work. Sorry to keep you waiting. I got my time mixed up. I thought it was 1:40. Sorry. All right. Let's go back to graphing. Now we have this new method. We can graph very quickly, and we know more about it, even whether we graph it or not. We know what the slope is instantly and what the y-intercept is. And the slope and the y-intercept tells us very important things about the situation. Let's look back. Remember this one? The rent a mountain bike. When we have the equation over here, y equals 3x plus 2, immediately tells us the y-intercept in this case has a particular interpretation. It's the starting cost, and the y-intercept in general, y equals mx plus b. The b usually represents something to do with what happens at the very beginning, at the start. As if you rent that bike even for 30 seconds, $2. Okay, and then the other thing tells you how fast your costs go up. They go up $3 for every hour. That's the slope, the rate of change of things. So you're getting the big information about how these two variables are related to each other right here. The more important of these two really is the slope, because every time the x goes up by 1, the y is going to go up by 3. Its change gets magnified by 3 right over here, and this is the one-time starting position. And so, like, if you were a big-time bike renter, you know, that $2 fee maybe not bother you, but, you know, as you're renting for lots and lots of hours, this is the more important thing, that slope. All right, so that's why there's a bunch of reasons why we prefer to put every equation that when the x is to the first power and the y is to the first power, we like to put them into y equals mx plus b format, and then use that to solve it and to graph it. Alright, so let me give you a minute to get ahead of me. 3x plus 2y is equal to 1. Solve that equation for y. So then you'll be putting it into y equals mx plus b format. And then graph it. And I'll do that in just a minute. So this one, 3x plus 2y is 1. I move the 3x over. Divide by 2. There's two ways to do this. Put one giant fraction bar, but then I won't have it into mx plus b format. So I do every term gets its own, divided by 2. And then I could put the x in the upper part of the fraction, but I prefer to do it like this. Okay, so this is clear that the m is -3/2. If I'd have put the x up in the top, it wouldn't have been quite so clear. It makes it really super clear. And the b is 1/2, so now I'm going to graph it. Let me give you a quick 15 seconds to make a graph ahead of me. So it's 1/2 is the y-intercept. The slope, put that negative sign with either the top number or the bottom number, doesn't matter which, you'll get the same line in the end. So now I'm going to rise -3 and stay halfway between -2 and -3, and then I'm going to run 2 and then I'm going to connect these two. To have my line. Okay. Any questions? So we could have done this, relating it back to our old method. We could have done it by the intercepts method. We could have done, x, y, pick 0 and 0, and that goes pretty quick, but we prefer even this because we graph it basically just as fast, maybe even faster, but we also get this better information, where this starts out at and how things change. We get that extra information here. So that's why we kind of abandon that after a while, preferring this. Alright, so now we're going to change it up slightly. A line contains these 2 points. Find the slope of the line and graph the line. So let me give you a minute for that. So, to find the slope, it didn't say which way to find it. We did them it 2 different ways. One by looking at the graph and finding the rise and the run. One by using algebra. The quicker way is algebra, so that's what I'm going to use. The difference in the y-coordinates, and you have to be consistent. Rightmost minus the leftmost. And then rightmost minus the left, difference in the x-coordinates. Don't take necessarily the bigger minus the smaller. If I'd have done 4 minus 3, I'd be getting this wrong. You got to go, you think of this as the first point, and this is the second point. So the second point minus the first, like this. This gives me -1 over 2, or -1/2. That's the slope. Now, we're going to graph the line. The line, well, it goes through the point 0, 4, and it goes through the point 2 over 3 up. And we're going to connect these 2 points. There's the line. Alright, now let's go down to the next one. Now it says, write the equation of the line. And I'm going to open the microphone to anybody. Anybody have a suggestion as how in the world can I write the equation of that line? I see it, but how do I write its equation?
Would you start with using that y-intercept and having that do like equal the y-intercept? I can't see what it is, but whatever that is, and then
0,
you'd
4.
find. And that would actually no, that would be plus 4, and then you'd have you'd find the slope and multiply that by x.
Ah, you're right on track. What we do when you're asked to write the equation of a line, you just impose this format. And then you just fill it in. You were telling me you look at the y-intercept and you see that this is 4. And we look at the slope that we computed. This is -1/2. So then we have all the information now. The equation of the line is y equals -1/2 x plus 4. That's the equation of this line. We're used to going backwards from this. We're used to like saying, oh, I could take this equation and say, oh, its y-intercept is 4, and I'd put an x there. And then I would go down 1 and to the right 2 because the slope is -1/2. And then I could draw it from there. But we could also just look at the y-intercept and the slope and construct the equation of the line. That is really huge for us. This could be really, really helpful to us. Any questions? Okay. So this next problem, a line contains a point 0, 2 and 2, 8. Find the slope of the line, graph the line, and then write the equation of the line. And I'm going to give you a minute for this. And especially when you get to the equation of the line, share that in your group. And anything else, the slope or whatever, and then I'm going to call on the group in a minute. Excuse me. Okay, 30 seconds more. All right, so let me ask group 3. What'd you get for the slope?
Looks like we got 3.
3?
Yeah, I'm sorry about that. I believe we've got for the slope, you said?
Yeah.
Okay. Well, let's see here. 6 divided by 2, I believe.
Yep. Which reduces to 3. Well, that's it. Okay. So now we're going to graph this line. We'll just put these 2 points on there. 0, 2, and 2, 8. So I draw what the line looks like. And then I got to get the equation of the line. Alright, so group 3, do you have the equation of this line? Group 3, you got anything for that? And if you're not there yet,
I can answer.
Okay.
Y equals 3x plus 2.
Okay. So we're going to start with mx plus b, and this goes here. Y coordinate of the y-intercept goes here. Now, it would be wrong to put another equal sign, because you need just one equal sign per statement. Y equals 3x plus 2, just as Amelia was saying. There is the equation of this line. Sometimes we put it right next to the line. Alright, and then let's go to number 6. Number 6 is much worse. It looks very similar to number 5, but why is number 6 going to be harder to find the equation of the line? Does anybody see why number 6 is harder than number 5?
I'm just guessing. Oh,
Yep.
Go for it.
Mm-hmm. Go ahead, go for it.
Because the point doesn't have a 0.
That's right. There is no y-intercept. So this is going to be tougher. Alright, we can still, let's find the slope. And we'll do this together here. I'm writing, here we go. M equals 8 minus 2 over 3 minus 1, 6 over 2, which is 3. Alright, now I'm going to graph the line. So let me blow it up a little bit. 1, 2, and 3, 8. Zoom out. Okay. Alright, so there's the line. And now I need to get the equation of the line. We'll start just like we did before. But we only have one thing to plug in now. The 3. We know the m is 3. So I'm just going to go ahead and plug it in. And maybe I'm going to need a little more space. I'm going to get y equals 3x plus b. Now, does anybody have an idea of how I might get this b? If I can get that b, then I've got the full equation of the line. It's not showing up here. How might I get it? Anybody?
Just draw out the line and then see where it hits the y-intercept?
Very good. So we can look graphically at it. And what does it look like? Where does it look like it hits? Maybe about -1? All right. Looks like it's -1 from the graph. Alright, but maybe it's almost -1, but just a little bit off from that. How could I find it exactly precisely? There's also an algebraic way to find the b. And we'll find it algebraically by doing this. Now this is, you have to understand the essence of an equation that has two variables in it. An equation that has two variables is really a relationship between two things that are changing together. Like x, see, this is the same kind of equation. It has a slope of 3 that was like the mountain bike thing. If the b was like 2, then this would be, x would represent hours and y would represent the cost. So it's this relationship between these two things that's the important thing. And when we have specific points, they are points that can be seen like this. When x is 1, y is 2. When x is 3, y is 8. They get to play the what if game. What if I rented it for 1 hour? What would be my cost? What if I rented it for 3 hours? What would be my cost? So on. Now this doesn't really represent that situation because the b is going to be different here. But it's we can use kind of the thinking that we developed over there. It's this relationship between the two. And so this looks like it has 3 unknown letters. Don't know what y is, don't know what x is, don't know what b is. But b and m are very different than x and y. B and m are what we call constants. Once we find them out, they never change. So for this problem, m is always 3. It doesn't change. And when we find out b, it'll always be that, and it doesn't change. But x and y are variables. And what does that mean? That means it comes right from the word variables. They vary. And I like to say they play the what if game. If x is 1, like I rented the bike for 1 hour, what would be my cost? If x is 3, what's going to be my cost? They get to do that. And we have 2 different cases for the what if game. All we have to do is plug in either one of those cases in here, and we'll figure out what the b is exactly. So let's try it with both numbers, and I'll show you we'll get the same answer. If x is 1, y is, let's look back up here, x is 1, y is 2. We're going to plug those in. The 1's going to go into here, the 2 is going to go in there. So I'm going to get 2 equals 3 times 1 plus b. Subtract 3 from both sides, and we're going to get b equals -1. So what it looked like on the graph was really accurate. B was -1. Now, I could have plugged in any point to get this. So, I could have plugged in 3, 8. Well, let me show you. If I had plugged in 3, 8, if If x is 3, y is 8. Plug those in. 8 equals 3 times 3 plus b. So we're plugging that into here. We get 8 equals 9 plus b. Subtract 9 from both sides. B would have to be -1. We get the same value. So write the equation of the line. It started y equals mx plus b, but it becomes y equals 3x. We knew the m was 3. And now we found out two different ways that the b is -1. So you could put plus -1 or just subtract 1. There's the equation of the line. Any questions? Okay, so Freddie, you had 2 questions from the homework. What were
Yes.
they again? 3.4 number...
36 and 42.
Okay, so number 36 says, graph the line y equals -2x plus 3. Now you know how to do that. Okay, so
Okay.
let me just insert real quick.
I just wanted to, even though I know how to do that, I just want to make sure that I am correct. Just want to make sure.
You bet. That's a good idea.
Yeah.
So this is 3.4, number 36.
Mhm.
Y equals -2x plus 3. They tell us to graph that.
Mhm.
That has a y-intercept of 3 and a slope of -2 over 1. So it's going to go down 2 over 1. And that's going to be this. And then it says, then name the slope and the y-intercept by looking at the graph. So the slope, by looking at the graph, says, oh, it's got a rise of -2 and a run of 1. So this would be -2 over 1, which is -2. But this number will always agree with that number if it's in y equals mx plus b format. And the y-intercept, from just looking at the graph, is 0 over 3 up. But the y-intercept always agrees with this number if it's in y equals mx plus b format. It's just emphasizing all of that. Does that make sense, Freddie?
Yes, it does. Perfect sense.
Okay, and what was the other one?
42.
Okay. 42. Find y if the line through 2, 3, and 5y has slope 0. Find y. Alright, so I know how to find the slope from 2 points. You take the difference in the y coordinates divided by the difference in the x coordinates. And now we're told that the slope is 0. So I'm going to get this equation. 0 equals y minus 3 divided by 3. And then what I'm going to do is multiply both sides by 3. So these cancel. I got 3 times 0 is 0. Add 3. And y is equal to 3. And that's all they asked us to do, is find y. And 42. All right. Any questions on this? Any questions so far?
No, I believe I got it.
Great. All right. Last one. We only have 4 minutes, so I'm going to kind of do this one, but I want you to see it in an application concept. Your chicken lays the same number of eggs every day. On day 2, there were 5 eggs. On day 7, there are 20 eggs. Draw a graph. First thing I have to do is decide what goes on the x-axis. Freddie, I think your mic is still open. And then what goes on the y-axis. And whenever time is involved, that's usually the independent variable. So the x will be the days. Because you have no control over time passing along. So it would not make much sense to put time as the dependent variable. And then this is the number of eggs. Y eggs. And on day 2, there were 5. So you see this, we turn into a point. On day 7, there's 20. Now day 7, the 20 is up beyond the scope here. Alright, but we'll imagine that that's at a height of 20. Okay, so we drew a graph. And now, since it's laying the same number of eggs every day, it's going to increase by a regular amount every day, and it's going to be a straight line going up. Okay, then it says find the slope. Well, the slope is the difference in the y's divided by the difference in the x's. over 5, which is 3. Now, the slope being 3 means, zoom this in. The slope is 3 means every time you run 1, you rise 3. Run 1, rise 3, so on. Okay. Because this 3 is a fraction. 3 over 1, and it's rise over run. Find the equation of the line. Alright, so I'm going to write y equals mx plus b. I don't know what the b is, because it gave us 2 points, but neither of them, 2, 5, or 720, had a 0 for its x-coordinate. So all I can do is plug in the 3 for the slope, and then I can plug in one of the known points. Let's plug in 2, 5, since the numbers are smaller. So the 5 goes in for the y. 2 goes in for the x. So I got 5 equals 6 plus b. Subtract 6. I get b on this side, -1. Turn it around, b is equal to -1. So now the full equation is y equals mx plus b with the m and the b filled in. When I put the b in, it's -1. Y equals 3x minus 1. And then once we have this, we can use it to find answers to questions like this. Use the equation to find the number of eggs on day 365. Well, I just plug in, since x was the day number, I just plug that in there. Y is equal to 3 times 365 minus 1, and I get 1,094 eggs. So you might be wondering, how many eggs do I get per year, kind of a thing, and it's over 1,000. All right. So this is how modeling things with equations could be very helpful to us. And so the homework is 3.5. It says to go through 62. I'm going to have you, I'm going to wipe off the last part of that assignment, because I want you to be spending time getting ready for the final exam and stuff. So the assignment is 3 through 54. Multiples of 3. And then it says 55 through 62 all. Let's knock that out of there. Just do this part. And I'll modify that in the assignment list on Canvas. And is there any questions? Alright, so this was our last regular day of class. I will see you in a week, Wednesday, for the final exam. We'll basically, you're just going to take the final exam, but we can have a real brief check-in on Discord right before you take that.
We'll be having class on Wednesday next week, not Monday.
No, yeah, there's no classes during final exams week. There's just final exams. So nope, today was the last day of class. Yep.
All right.
Nothing on Wednesday. All right, it's been a pleasure on my end. And if you guys need anything in the future, need any recommendation of which class to take, which instructor to take, I'm always happy to give that information. All right.
I really enjoyed this class, sir.
So did I.
Shame we couldn't do it in person, but this was pretty good.
Yeah, it's the best we could do under these circumstances. Huh?
Yeah, thanks for taking the time to help us out and doing a great job teaching.
Oh, thank you very much. Well, and it really depends on how everybody responds, and you all responded great. So thank you all as well.
I also wanted to thank the members of my group, Jacqueline and Ashley. You all did a fine job. I wanted to thank you all for everything that you did in this class.
That's cool.
Yeah. All right, so I'll see you next week.
Okay, see you next week.
Uh,